Exercise 10.8 is notably different from the previous exercises in the sense that in the previous exercises we were given a production function and we needed to derive the short-run or long-term cost function. In exercise 10.8 we are given a cost function instead and we need to derive the production function. So the cost function is given here and question A asks us to use Shepard's lemma to compute the demand function for each input, capital and labor. So actually we are asked to compute the contingent demand for capital and labor. We're given one hint that we need to use Shepard's lemma, so that only simplifies the exercise. And before applying Shepard's lemma, we will do one further notational simplification. So I will define capital B as the sum of square root V square root W because it eases our notation, makes it somewhat more transparent. So our cost function, this is the original cost function, and you can note that the term within parentheses can be rewritten as square root V plus square root W squared. We define this to be capital B, so our cost function simply reads Q times B squared. That said, we apply Shepard's lemma. Shepard's lemma says that the contingent demand for capital is derived as the derivative of the cost function with respect to the cost of capital. So we take the derivative of a cost function with respect to V and we arrive at the expression that is given here. And with our capital B notation we could also write it as Q times B times V to the power minus 0.5. Similarly, we again apply Shepard's lemma to derive the contingent demand for labor, taking the derivative of the cost function with respect to W, and we get an expression that is very similar. And this already completes question A. Of course, there was no need for you to introduce this capital B notation. To answer question A, it would be sufficient if you had a term that is given here and here. But we will use that capital B notation when going to question B. Now, what is question B? Use the results from part A to compute the underlying production function. So from question A, we know the contingent demands, and we also know that the ratio between the contingent demand for capital and labor is equal to the square root of W over V. Now, that's not that easy to see maybe from these first expressions, but here the notation with the capital B comes in handy because it is easily shown if you divide KC over LC, then the Q and the B drop out both, and you are left indeed with the square root W over V. So this also implies that if we would square both the left-hand side and the right-hand side, you would have that the ratio of W and V needs to be equal to the contingent demand for capital and labor squared. Okay, so this implies that the marginal rate of technical substitution is identical to K over L squared, because in equilibrium the marginal rate of technical substitution needs to equal W over V, and W over V is equal to this K over L squared. And now we can substitute this marginal rate of substitution into the contingent demand for capital. So what we do is we actually replace the square root W over V over here with the expression that we have over here. And doing so, okay, we simply replace this one with K over L. And we have an expression in the form of K, L, and Q. Now we need to derive the production function, so we solve this equation for Q. And if you rewrite this a little bit, so you free up Q, meaning that Q is identical to K over L plus 1. And then rewriting a little bit more, you get the following production function. And what is omitted here should also be a Q behind the parentheses. So because the only thing that changes here is that we replace the square root over here by K over L. Here appears a Q, and it should also appear here. And then solving for Q gives us this production function. Now, another way to do it is, this is question A. From these two expressions, you have that if we bring this part to the left-hand side, that you have and the Kc to the right-hand side, we can rewrite this as Q over K should be equal to V to the power 0.5 divided by B. We can similarly rewrite this expression over here as Q over L should be W to the power 0.5 divided by B. From that, it follows that Q over K plus Q over L, summing the left-hand sides and summing the right-hand sides. If you sum the right-hand sides, we have a common denominator equal to B. So we can simply sum these two terms, V to the power 0.5 plus W to the power 0.5. But here you can see that this is exactly identical to how we defined capital B. So actually what we have here is capital B divided by capital B, which equals 1. So and this is an alternative way to derive the production function. So we arrive at an equation Q over K plus Q over L is equal to 1. Again, we solve for Q. So we can simplify this as follows by freeing up the Q. Should be equal to 1. And then we solve for Q and we get the same expression as on the previous slide. And that completes the exercise.